Hey everyone, welcome back to the channel. This is Rob. I know that it has been a while and I've been really trying to get a video out, and the way things have been lining up, I haven't been able to until now. So one thing on my mind that I've been pondering lately is the concept of a routing loop. So I'm sure we're all familiar with layer 2 loops, where we need to utilize something like spanning tree protocol to prevent a layer 2 loop, which could cause multiple different issues, the most severe being a broadcast storm, which could take down the entire network. But with layer 3, loops are less common. Most times non-existent, except when you have a situation where, and if you look, you'll see this GNS3 topology I have right here, where you have a mutual redistribution points in your network. Now let me explain that. If you look over here, you will see that we have a bunch of routers in a circle or a diamond, or however you want to see it, but they're all connected together. And so R1 is running BGP, and there are BGP adjacencies formed between R1 and R2, R1 and R3, and then we also have this BGP peer. The reason for this is just so we can advertise a loopback into this network, and the loopback is it's just 1.1.1.1. So I'll just drag this over here and give you a little peek as to what's going on with that. So I'll issue the show IP interface brief command, if I can spell. And if you look, we have loopback 0 with the IP address 1.1.1.1. Show run pipe section router BGP. And you see that we're advertising that network into BGP. So what that means is that this BGP peer is advertising 1.1.1.1 down to R1, and then R1 is advertising that to R2 and to R3. And then R1 is also a route reflector for anybody that's interested. Since this is iBGP, and iBGP routes won't propagate after the next hop. So if it wasn't, then 1.1.1.1 would stop here. So this is a route reflector, so it can reflect those routes, or that route, should I say in this example, to R2 and R3. So far, not a problem, right? Well, R2 and R3 are both also running OSPF. So we have OSPF adjacencies between R2 and R4 and R3 and R4. And here we have kind of the same thing over here, like we do up here with this BGP peer. We have an OSPF peer. Purpose for the OSPF peer is just to advertise another loopback into the network, using loopbacks to simulate a network coming off of this router. And it just makes it easier when you're doing a lab to use loopbacks instead of actually connecting up a host or a switch or whatever. So I'll go show IP interface brief, and we see that we have 2.2.2.2 and show run pipe section router OSPF. Oh, that's right. Losing my mind a little bit after you get used to like BGP, and then you go back to an IGP like OSPF, and so let me go show. I mean, you can add the network statement under OSPF, but I try to do it under the interface. So show run interface loopback 0. We have that IP address 2.2.2.2, and you can see that it is part of the OSPF process. So what I'm going to do, so I'm just going to, I should have done this before, but I didn't, so just bear with me. So I'll put 1.1.1.1 right there, and 2.2.2.2 right here. So 1.1.1.1 is being advertised here to these routers. 2.2.2.2 is being advertised up here to these routers. You're probably thinking at this point, Rob, why are you showing me this? Well, the reason I'm showing you this is because on R2 and R3, these are mutual redistribution points in the network. By mutual, what I mean is that we have BGP being redistributed into the OSPF process. We also have OSPF being redistributed into the BGP process. So, and we have multiple mutual redistribution points. And this is where routing loops can occur, because when you redistribute one routing protocol into another, you kind of muddy the metric a little bit. And it kind of takes away from, so like say you had a pure OSPF network. Once you redistribute OSPF into BGP, you kind of take away from that metric, muddy it up. And to give you an example, really quick, so like on OSPF peer router right here, where we have 2.2.2.2, let's just take a peek at R4. Just really quick here, and I'll issue the do show IP route OSPF command, and let's look at 2.2.2.2. We see the metric right here, which is 2. And let's go over here to R1 and see what this looks like in BGP. Since remember, we're redistributing here and we're redistributing here into BGP and then vice versa. So we'll go show IP route BGP. We're going to have the 2.2.2 in there, but it's going to be in the BGP process. You look at is the metrics different because we just redistributed it. The problem saying that into a different routing protocol. Okay. So what happens is, so I'll give you a brief background before I show you how to what you can do to prevent this. Is that let's look at now. I had to. I really had to screw around with this to make this actually work, because there are quite a bit of like safeguards put in place to prevent this from happening. One of them is that BGP, at least on Cisco devices, I'm not sure about other vendors, but it doesn't originally let you redistribute into another routing protocol. So you have to use the, so if I go in here into R2, for example, and I look at the configuration for BGP, so I issue show run pipe section router BGP, you'll see that I have the BGP redistribute internal command. So by default, it wouldn't let you redistribute BGP into OSPF. There's a couple of reasons for that. But I had to change a couple things around to allow this to work the way that I wanted it to, so I could give you this example. Now you might be wondering, oh, why didn't you just use eIGRP and OSPF? Well, again, those have safeguards built in that would actually prevent it from working the way I would want it to for this example altogether. So if you redistribute OSPF into eIGRP, we know the administrative distance for eIGRP is 90. Once it's at eIGRP external route, it is 170. Is it 170? eIGRP external AD is 170. So that would kind of prevent this from working the way I would want. And you're going to understand that right now because I'm going to explain it to you. So looking at this, we know that BGP or iBGP has an administrative distance of 200. OSPF has an administrative distance of 110. Now, the way it normally works is prefix length, administrative distance, and then metric to determine the best route. But with this, prefix length is going to be the same because it's just the 1.1.1.1 and 2.2.2.2, both /32s, just defining just a single IP address. So we're looking at administrative distance. So BGP peer says, hey, I've got 1.1.1.1 for you. Here's how you can get to it across this link right here. Now, I should have put the IP addresses on each end of these links, but I didn't. Where is BGP peer? I guess it really doesn't matter what the IP addressing is like as far as the point-to-point links are concerned, but I think they're in the 172 range. So if I do show IP interface brief gig 0/7, we have 172.16.1.1. So right here would be 172.16.1.1, and then 172.16.1.2, and they're all /30 links. So anyways, BGP peer says, hey, I have 1.1.1 for you. You can get to me via this link. So 172.16.1.1 is your next hop. Tells that to R1. R1, in turn, tells R2 and R3 about 1.1.1.1 as well. Now, we're redistributing BGP into OSPF. So, where we have an administrative distance of 200 for iBGP, once we stick it into OSPF, now it is now an administrative distance of 110. Now, this is the part that's, I don't want to say complicated, but it is, well, it's kind of random. It depends on which one of these two routers, whatever converges first, whichever one gets the advertisement for the network first is going to be how this will work. So we will just say that R2 ends up advertising, once we redistribute BGP into OSPF on R2, it advertises it down here to R4 and then back up to R3. Okay, now what's happening is that this is saying, R2 saying, I know how to get to 1.1.1.1. We're redistributing it into OSPF. OSPF has an administrative distance of 110. And now we're going to advertise that down to R4, and then R4 advertises that to R3, and R3 looks at the routing table, and it sees, because it already has a 1.1.1.1 from BGP, from R1, but the administrative distance of 200 is much greater than the administrative distance of 110 for OSPF. So the OSPF route is going to override the BGP route. Now, do you kind of see where I'm going with this at this point? Now, since we have mutual redistribution, OSPF is going back into, well, I don't want to say back into BGP. It's being redistributed into BGP. But in this scenario, the 1.1.1.1 would be redistributed. It would be placed, we'll just say it like this. It would be placed back into BGP, where originally it originated in BGP. Because now, and like I was trying to say, is that this could be flipped. I mean, this could be, R3 could be the first one to advertise this down here, and then R4 up to here, and then this could be the one that has the OSPF route for 1.1.1.1 instead, and then what's gonna happen is you're gonna advertise it back up to here. So now R1 in the BGP process is going to have two different routes to get to 1.1.1.1. Now, the difference is that when everything's connected, it's fine. It's going to work. There's no routing loop. I can show you that. I'll go to the OSPF peer over here, and I'll ping 1.1.1.1, and we're going to get a response. And that's because even though, again, whichever one of these routers converges first and redistributes that back into BGP, the metric will be upped 1. So let's go ahead and take a look at R1 BGP and look at the BGP process and see. And another thing, and really quick, I want to apologize. I just thought of it. I know on some of my videos I've had some minor complaints on the font, and for some people it's fine, but some people can't see the blue on the black, or if I've used green. I've intended to change that, and I have, but I'm using a different computer, and I didn't even think about this. So if you're having trouble seeing the text, I apologize. I plan to have that changed and this issue solved for upcoming videos. But anyways, if we look at the BGP process on R1 BGP, we'll issue show BGP. Whoa, what? Look at that. We have two different ways to get to 1.1.1.1. Huh. That's because one of the ways is 172.16.1.1. And again, I apologize. I should have labeled the interfaces with the IP addresses. But if you remember, if you've been paying attention, you would remember that this right here on this side would be 172.16.1.1, and this would be 117. I don't know why I keep saying 117. 172.16.1.2. So one path is to actually get up to where 1.1.1.1 actually is. But then we have this guy right here, 172.16.1.10. So if 1.1.1.1 went away, BGP would flip to this, which is going to send it back down to one of these guys. Now, to actually figure out which one is 172.16.1.10, let me just do a very small investigation. And yes, I could have been slightly better prepared for this, but it'll just take a second. So we'll issue show run interface gig 0/2. Of course, that's not it. So it looks like we're looking at R3. Have it open, console in. Drag the window over, and this is probably going to be it. So it looks like, so show run interface gig 0/3, 172.16.1.10. Okay, so now that we know that if we go back to R1 BGP, this is saying that we can get to 1.1.1.1 once again over here, which is where it exists, or we could get to 1.1.1.1 via gig 00 over to R3. That doesn't sound too good. And again, why is that happening? Well, just to kind of beat it into anybody's head who might be having an issue understanding it, and the only reason I'm doing this is because it took me a little while to grasp this concept. So I really want to just reiterate it as much as I can, and if you want to skip ahead in the video, you're more than welcome to. But just to reiterate this one more time, the reason for this is because we're advertising 1.1.1.1 down to R1 via BGP, which in turn is advertised to R2 and R3, where we are redistributing BGP into OSPF. So this is saying now our 1.1.1.1 is in the OSPF process, and it's telling R4, I know how to get to 1.1.1.1, and then R3 would be saying that, except for the fact that one of these guys is going to converge first and it looks like in this instance, since we see that the alternative next hop would be the 172.16.1.10, which would be R3's gig 0/3 interface, it looks like R2 was the faster of the two and told R4 how to get to 1.1.1.1, which in turn told R3 how to get to 1.1.1.1, redistributing OSPF into BGP now. Now R3 is telling R1 how to get to 1.1.1.1, and BGP put it into its process. Now we have a possible routing loop if this BGP peer were to go down. I hope that you're understanding this. I know that it is a little bit of it can be a bit of a complicated subject, and I will actually link another video in the description. Somebody that does an amazing job at explaining this, probably way better than me. So you can have you can look at that, and then that might help put things together even a bit better for you. So anyways, continuing on, let's see what happens if this BGP peer went down. And the easiest way to do that is I'm just going to shut down R1's gig 0/7 interface. And that should pretty much immediately take that out of the routing table for BGP. Unless we have to wait out the timers, which I didn't think we would have to do if I shut down the interface locally. Oh, no. It changed over. Okay, cool. So let's go over to OSPF peer, and let's ping 1.1.1.1. Of course, we're getting no response because now there's a loop. So now R3 is telling R1 how to get there. R1 is telling R2. R2 is telling R4. R4 is telling R3. R3 is telling R1, and it's going. And to prove that, let's say debug IP ICMP and see if we get an ICMP time exceeded message, because obviously the time to live will expire, and then it will send an ICMP time exceeded message. So with the debug on, let's try to ping it again, and we should get, oh, there we go, time exceeded, received from 172.16.1.5. So it looks like over here on R2, I believe that would be one of R2's interfaces. I think, but that would be where the TTL expired, and it's saying to OSPF peer, yeah, the TTL expired, so then the packet is dropped. So we definitely have a routing loop. Let me go back up to R1 BGP. No shut that interface. Do show BGP, get the switch back over to the correct route. And while I'm waiting on that, I'm sure somebody's wondering, but hey, what about on the opposite? What about 2.2.2.2 or 2.2.2.2 from OSPF into BGP and then BGP back into OSPF? Well, that's a little bit different because let's just think about it for a second. OSPF is advertising 2.2.2.2 to R4. R4 is advertising it to R2 and R3. Yes, we are redistributing OSPF into BGP in multiple points. So R2 will advertise, well, that would be redistributed into BGP, which will then advertise it to R1. And the same thing with R3. 2.2.2.2 will be advertised to R1. The difference is that, looking at administrative distance again, the administrative distance of OSPF is 110. BGP is 200. So if this 2.2.2.2 is originating in OSPF, and this is sending it up here and then to here, it's not going to, in BGP, BGP's administrative distance of 200 is going to lose in light of OSPF's administrative distance of 110. So the OSPF route will be the same in both. So both of these will have an OSPF route for 2.2.2.2, and then R1 will have a BGP route for 2.2.2.2. Unlike, once again, the opposite, where we have BGP advertising 1.1.1.1 to R2 and R3 into OSPF, iBGP, administrative distance 200, OSPF 110. We have one or the other. Again, we'll just say R2, redistributing that into OSPF. And so now, let's say it goes this way, goes this way. Oh, we had a 1.1.1 in here in BGP with administrative distance 200, but now the OSPF route, because it has an administrative distance of 110, wins. And so we'd get the OSPF route in there, which gives it a chance to redistribute it back into BGP. And that'll be the last time I'm going to explain it, because I know there's some people out there rolling their eyes right now like, okay, I get it. But just the reason I do this is for the people that don't. It's really hard to make a video sometimes because there are some people that learn faster than others, some people that learn slower than others. So if I go too slow, you get people that are, oh, you're going so slow. If I go too fast, you get people that say I go too fast. So I really try to make this the best way I can, so it's the best for both parties, types of people. And I figure it's probably better to go a little bit slower because you can skip ahead in the video. So if that's what you want to do, go ahead and do that. Put it on, up the play speed or whatever. But if I go too fast, that's something that can't, well, I guess you could lower the play speed, but... But anyways, so with that being said, let's just, before I show you how to tag these routes and fix this, let's go over to R2 and just look at the routing table. So like I said, we're going to have a OSPF route for 2.2.2.2 in both of these in the OSPF process. And 1.1.1.1, one of these is going to have a BGP route, the other one's going to have an OSPF route because of the looping and the administrative distance thing that I said I wasn't going to go over again, so I'm not. So if we look, we see that on R2 we do have the BGP route. So this is going to be the one that actually redistributed this into OSPF down to R4 and then R4 back up to R3. So I'm assuming if we look at R3, we're going to have a 1.1.1.1, but it's going to be OSPF. And it is. It's an OSPF external type 2 route. But let's look at R2 once again, 2.2.2.2, OSPF. R3, once again, OSPF. So we have a problem with the BGP going into the OSPF, and then the OSPF going back into the BGP. Original network goes down, routing loop. Boom. How can we fix this? We can tag our routes. And we can tag our routes using a route map. So, the way I think of it is that let's look at BGP. Now, with this example, we really just need to worry about the BGP routes going into OSPF and then OSPF going into BGP. So we could say, hey, BGP routes going into OSPF, give it a tag of 10, BGP to OSPF, and then OSPF to BGP, deny routes with the tag of 10. One thing I'm going to mention is that this example isn't going to work out the best way that I would like it to, because there is an issue where I think on the BGP side, it doesn't allow you to set a tag, and I really wanted to set a tag or deny the tag from the opposite and then set a tag. It's not going to work out that way, but this will still it'll still get the idea across, and you can still prevent this routing loop from happening. So what we're going to do is we're going to create a route map, and I'm going to name the route map BGP to OSPF. And then here's the important thing. We want to deny first, because if we permit and then we set the tag, then it's going to let everything else through. So we want to deny first. So we'll say route map BGP to OSPF deny 10. Now, let's look at what we have to deny. If we're going BGP to OSPF, we're going to set the tag. We'll set the tag of 10. So all BGP routes that then exist in OSPF will be set as 10. And then OSPF into BGP, we will deny 10. So looking at the opposite, now, of course, if you remember what I said earlier, this part is actually technically unnecessary because we don't have a problem with OSPF going into BGP because of the administrative distance. But just to kind of give you the fullest example I can, we're going to do it anyways. So going from BGP to OSPF, we want to look at OSPF going into BGP. We'll give it a tag of 10. I'm sorry, a tag of 20. So when BGP goes into OSPF, we don't want those original OSPF routes to end up back in the OSPF process. So OSPF to BGP would be a tag of 10. BGP to OSPF will deny, 20. I apologize. OSPF into BGP will give it a tag of 20. And then BGP into OSPF, we will deny 20. Which this might be the one where BGP doesn't allow you. No, it'll allow me to deny it. So yes, so we'll say BGP to OSPF, deny 10. And I will say match 20. Match tag 20. And then we will same route map name. Now it's probably not gonna like this when I put it into BGP. It's just a BGP thing. But again, I'm gonna do it anyways. Route map BGP to OSPF permit 20, and this is where we're going to set our tag to 10. Set tag 10. Now we can go into, actually it will allow this because this is under the OSPF process. So if we go router OSPF 1 and then do show pipe section router OSPF, I just want to get rid of the redistribute statement so I can re-add it with this route map. And then route map, and we'll just copy this, BGP to OSPF. Okay, so we do show route map and then BGP to OSPF. So once again, we're denying tags of 20, which would be OSPF into BGP. So when it comes back around, we don't want anything with a tag of 20 going back into OSPF, if that could ever be the case. And we want to set BGP routes going into OSPF with a tag of 10. So essentially, since we put that in there, now we do have to do it on R3, which I'll just copy and paste at that point. But what this means is that 1.1.1.1 in OSPF will have a tag of 10 at this point. Okay? And I'm going to show you this when we're done. So let me kind of speed this up a little bit. Hopefully you're getting the gist of it. So the next thing to do is route map. And I think this is the one I was talking about that it's not going to like. When I go OSPF to BGP, and we'll go deny 10. Now, I hope this is making sense. And if it's not, hopefully it will in a second here. But OSPF to BGP, remember, BGP to OSPF, we gave it a tag of 10. So BGP, so 1.1.1.1 to these two guys, once it's in OSPF, it has a tag of 10. So this is how we're going to prevent this routing loop. Once OSPF goes into BGP, we're going to say deny. So we'll say match tag 10 under our deny statement. So this is going into from BGP to OSPF. It's being simultaneously tagged with 10, and then OSPF to BGP will be, if you have a tag of 10, you're not allowed to be redistributed into the BGP process. Now this is the part it's not going to like. This is the way you would do it with any other routing protocols. I don't know why BGP wants to complain about it, but we'll do it anyways once again. So we'll do the permit and then line 20 and then set tag 20. And you'll see what I'm talking about, because when I go to put this, oh, spelling error. When I go to put this into, plug this into the BGP process, BGP is going to complain about the setting of the tag 20. So we'll go router, BGP 1, get rid of the redistribute OSPF 1 so we can re-add it with the route map. And route map OSPF to BGP. See what I mean? Set tag not supported. I don't know why. I don't know if there's a separate command for it. I could have sworn I had this working like that before. But again, we don't really need to worry about the set tag because, again, we're not worried about OSPF, routes originating in OSPF, going into BGP, and then back into OSPF because the administrative distance thing, it won't allow for it. Unlike vice versa. Anyways, I hope the deny tag 10 still works. I actually haven't tried it like this before. I'd normally just take that line out when I see that, but we're going to try it anyways. So here we go. We have that configured. Now let me just do this so I can copy and paste this into R3. Do show run pipe section route map. And I'm just going to take all of this that I just created, and we're going to paste it over to R3. So they both have the same route maps configured on them. There we go. And we will plug them in, just like we did over there on R2. So router OSPF 1, no redistribute BGP 1 subnets, and put that back in there with the route map. What are we in? OSPF. So BGP to OSPF would be the correct one. Do show run pipe section router BGP. Router BGP 1, no. Oh, that's weird. I don't know why I didn't have the on R2 the match internal external type 1 and 2. I don't know. Well, either way. All right, route map. So we're in. So OSPF to BGP. It's going to give us that warning again. But who cares? Okay, so we have tagged the route. So once again, BGP routes going into the OSPF process will have a tag of 10. OSPF routes going into the BGP process will have a tag of 20. So we want to, this way, tag with 10, and then back up this way, we want to deny 10. Up this way, we want to tag 20. Back down this way, we want to deny 20. And let's take a look and see if this has taken effect yet. Let's go over to R1. And at this point, that looping route should be gone. And it is. We only have one route to 1.1.1.1. Why is that? Let's say show IP route 1.1.1.1. And we should have a tag in there. Or No. We will not have a tag for that because it's originating right there. What am I talking about? We want to go on R4 where it's BGP is redistributed into OSPF because that's where the tagging will happen. So let's go to R4. Show IP route 1.1.1.1. Tag 10. Okay, so you see that this route coming down here, and then is tagged with 10 on the BGP to OSPF side, and then the OSPF to BGP side, we have that tag of 10 blocked. So since we have in OSPF to BGP deny routes with tag 10, this 1.1.1.1 is tagged with 10. It's no longer able to be redistributed into BGP and go back up to the BGP process, which is why we have just this now. Not bad. Why we have just this now. We don't have that additional 172.16.1.10 is the next hop, like we saw. Is it still there? Way up there? Yep. Like we saw up here before we tagged our routes and applied those route maps. All right, that's pretty much it. I actually really intended for this to be a short lesson, but I guess it's one of those things. It's really kind of difficult to get out in a short period of time. So it looks like we're going on 40 minutes. So I really hope that I was able to explain this in a way that was informative. And actually, before I go, if you want to hang out for one more moment here, I just wanted to give you one more quick example of something. Let's just say, for example, this was not BGP. Say this was EIGRP with an administrative distance of 90. So we're redistributing 1.1.1.1 into OSPF, and so we have an administrative distance of 90 with EIGRP. Once it goes into OSPF, we're going to have the OSPF or the EIGRP route for it, because 110 is obviously greater than 90, so we'll have 1.1.1.1 in R2 via EIGRP, and then same thing with R3, because OSPF's AD of 110 is not going to override EIGRP's administrative distance of 90. Now, vice versa, you might be thinking, oh, this could be another routing loop, but listen to this. So we have 2.2.2.2 going up here, and then being advertised to R2 and R3, and then, of course, administrative distance of 110 for OSPF. And then once it's in EIGRP, administrative distance of 90, right? So you would think that, oh, well, one of these, whichever one converges first, will then send 2.2, we'll say it's R2 converges first, sends that up here to R1, and then over here, and then that will override the OSPF route, and then we're redistributing EIGRP into OSPF, which will then do the same thing as we had with BGP, except reverse. It would be redistributing 2.2.2.2 back into the OSPF process. That's not correct, and I'm sure a lot of you watching have already figured this out, is that as soon as we put this OSPF into EIGRP, and I believe I mentioned this, I did, because I have it right here, EIGRP external routes are AD 170. So if you have multiple mutual redistribution points between OSPF and EIGRP, shouldn't actually be a problem, because that's going to be, like, again, 2.2.2.2 up here to R4, and then here and here. Once it's redistributed into EIGRP, the AD is now 170. 170 is greater than OSPF's AD of 110. and therefore we are safe. I would still recommend anytime you do have multiple mutual redistribution points to just tag the routes anyways. That's just, I think that would be best practice, just so that way you don't have to worry about it. And really, who wants to worry about stuff like this? It's a pain in the butt, and it's just an unnecessary hassle if you have to diagnose some sort of routing loop down the line when you could have just done this originally. So that's pretty much all I have to say about it. I hope this was helpful. If you have any questions, feel free to reach out. You can leave a comment on this video. Please don't forget to give it a thumbs up. If you enjoyed it, subscribe to the channel if you're not already subscribed. And you can also reach me via email at rob@rmtechcentral.com. I'm going to link that other video I mentioned earlier in the description, which is a more thorough... it's just a really good video on routing loops. So if you're still kind of stumped by it and you want to check out somebody else's video on it that I highly recommend, click the link in the description and you can go to that video. Once again, thanks for watching. Really appreciate it, and I'll see you in the next video.